Welcome to qnawire.
In this question, we have a PV diagram of an ideal gas, and then it underwent several processes. We are given that from A to C, the curve path, the Q is negative 85 joules, the W is negative 55 joules. And then in part A, we want to find the change in internal, the E internal A minus E internal C. Okay. Right. So there are 5 parts, and then we'll do part by part. Okay. Okay, so in part A, we want to find E internal A minus E internal C. Okay, so we'll be using first law of thermodynamics. Okay, which says that delta E internal equals to Q minus W. Okay, and this delta internal is delta E INTC. No, okay, is E internal C minus E internal A. Okay, but the question wants us to find the opposite. Okay. So, but we still find the Q and W. So we are given that Q is negative 85, and then the W is negative 55, and you get negative 30 joules. So E internal of A minus E internal of C is equal to 30 joules. Okay, so this is the answer for part A. Okay, then in part B, okay, we are given that okay, we want to find the Q in the process CDA. Okay, right, so part B, okay, we want to find QCDA. Right, so we are given WCDA is 38 joules, and then delta E internal A to C is equal to 30 joules, right? So from first law of thermodynamics, okay, delta E internal equals to Q minus W. Okay, Q is delta E internal plus W. So we have 30 plus 38 equals to 68 joules. Okay, then in part C, we want to find the work done in the process ABC. Okay, right, so WCDA is the area under PV diagram, area under the graph. Okay, so okay, if you look at the diagram again, okay, so this is just a rough sketch. Okay. Okay, so for CDA, okay, it contains the area under the graph is this part. Okay, so from the diagram, it's just PD times VD minus VC. Okay, and then to calculate WABC, okay, WABC means we need to have to include this additional area. Okay, but we are given that PA is okay, so it will be PA times VB minus VA, right? Okay, but this is 2.2 PD. Okay, VB is VC, and then VA is VD. Okay, so if you look at this, it's 2.2. This one is given to be 38 joules. WABC is given to be 38, and okay, and over here PD times VC minus VD is negative 38. Okay, so you get negative 84 joules. Okay, as the answer. Alright, so then in part D, we want to find the Q in ABC. Okay, Q in process ABC will be using the first law of thermodynamics. Okay, delta E internal is equal to Q minus W again. Okay, so Q ABC is delta E internal from A to C. Okay, this one is negative 30. Okay, from A to C is negative 30. From C to A it's positive 30. And plus W. So you have negative 30 minus 84. You get minus 114 joules. Okay, so this is the answer for part D. And then in part E, we calculate the Q for the process BC. Okay, so to do this, first we need to recognize that QABC is QAB plus QBC. Okay, so we need to find QAB first, then we are able to find QBC. Okay. Okay, then we also need to recognize that WABC is equal to WAB plus WBC. Okay, but since WBC, B to C is an isochoric process, there's no area under the graph, so this is WAB, and this is negative 84 joules. Okay. Okay, and then we are given that delta, if you look at our given information right at the top, we have this. Okay, E internal A minus E internal B is 15 joules. Okay, so if you use first law again, okay, this time A to B. Okay, A to B is the opposite of B to A. Okay, the one that is given to us is B to A. Okay, is equal to E internal B minus E internal A. Okay, so this is negative 15 joules. Okay, so and this is equal to QAB plus minus WAB. Okay, so we can find QAB to be delta E internal A to B plus WAB, which is negative 15 plus negative 84. Okay, and you get negative 99 joules. Okay, so if we go back to the first line, QABC equals to QAB plus QBC. QBC is equal to QABC minus QAB. And we have negative 114 joules plus 99 joules, and you get 15 joules, negative 15 joules. Okay, so this is the answer for part E. And that's all for this question.